row echelon, and today we will also talk about the difference between the two. How do we use them? At what point do I need to stop when I'm asked to reduce or to solve a particular system of equation? So any questions so far? Can you see my page? Can you see the button?
Yes, we can see it.
Okay, thank you. So like I told you, we continue from where we stopped last time. So for today, let's look at the row echelon. Let's look at today's, say that's echelon form and reduced row echelon form. So in this case now, what we need to do is when we mention echelon form, what is the echelon form means? Echelon means echelon form. It says previously we call it previously called triangle form. Previously called triangle form. What are the things we need to take note when you are working in this particular area? Number one thing you need to know is all non-zero row are above all non-zero row above all zeros, all zero row. 2. Each leading entry of a row is in a column to the right of the leading entry of the row above it. 3. All entries in a column below a leading entries, are zeros. Number 4, The leading entry in each non-zero row is 1. Number 5. Each leading one is the only non-zero entry in the column. So now let me give you an example. So we have these 5 characteristics that I want you to know. Examples. Where we have, let's say we have 12, 6, 4, 3, 2. Then we have 0, 2, 3, 8, -1. 0, 0, 0, 5. Zero, 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 zero. I said this is 7. Now, one of the things I want you to know is this. Look at this, is what we call leading entry. These are the leading entry points, entry values. These particular matrix, we call it echelon. This is what we call echelon form. Simply means that our leading, just look at it. The first one says all non-zero row are above all 0 rows. Now, if you look at, let's look at this one. This is, let's say, this is row 1, row 2, row 3, row 4. Now, look at the row 4. Everything here, they are zeros. So, the non-zero means those ones that they are not entirely 0. They are above the one of 0 point. 0 rows are below. Then he said each leading entry of a row is in a column to the right of the leading entry of the row above it. So you can see that we are moving towards right in this case. Then all entry in a column below the leading entry are zeros. All entry. So when you are working, you can see that all entry below the leading column, below the leading entry point. Look at it. The entry below this one is 0. 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 So take note of these characteristics. They are very important. Then, the leading entry in each non-zero is 1. So these are the ways, that's where you now need to work on it to reduce it further to make sure it is 1. That is when it's now. So from 4 and 5 now lead us to reduce row echelon form. So now from here, now the same thing will now lead us to this 1 0 0 0. Let's say this is 2 0 0 1 0. Let's say this is 3 0 0 0 1. Let's say this is -2 and this is 0 0 0 0 0. So this form, we call this second form, we call it reduced row echelon reduced row echelon form. So in this case, it said the leading entry, the leading entry, the leading entry, don't forget, the leading entry in each non-zero row is 1. Look at the leading entry here. The leading entry here is what? 1. Each leading 1 is the only non-zero entry in the column. This is what we call a column, column 1, column 2, column 3, column 4. You discover that it's the only one that is the value that is non-zero compared with echelon form. Echelon form, they have many in that particular column. But when it comes to reduced row echelon form, you have C1, C2, C3, C4. That is column 1, column 2, column 3, column 4. And we have them as row 1 here as a leading one, row 2, row 3, and row 4. So I hope you can see the difference between the two. When you are working and you are asked to do something on this particular aspect, that's the meaning, or that's the difference between the two. Please let's take note of both echelon form and reduced row echelon form. Any question? So that leads us into what we call pivots. On pivots, let's look at the example of pivots. Example of pivots is we have so many things that is on pivots that we need to check. Number one, we need to check is this. Let's look at this. We have 1, 3, 2, 4, 6, 0, 0, 2, 5, 4, 0, 0, 0, 0, 0. So in this case, we have, let's say we have this. Then, so we have this. Now, in this case now, we have what we call a pivot. The definition now comes in saying the pivot position says this said correspond pivot position correspond to leading one, one, we know them. In reduced row echelon, form. Then we have, that's the pivot position. Then we have a pivot column. That the column that contains the pivots. The column that contains the pivots. Then the pivot itself, it is non-zero number. In pivot position. Used to create zero in row operation. Used to create the row in row operation. So these are what we call the pivots. But let's look at the example and let's see how we can make use of one or two. Then we can now see the what we call the pivots, then the free variables, and so on. Let's look at the example first. Example. So when you have x1, let's say minus 3s3 equals to 8, then s2, x1 plus 2s2 plus 9x3 equals to 7, then s2 plus 5s3 equals to minus 2. In this case, first thing you need to do is to write your augmented matrix. The first thing is to write augmented matrix. We are trying to solve, we are trying to work on the row reduction algorithm. We're trying to write it. The row reduction algorithm. But let's see how it works. So the first one is 1. You discover that equation 1 does not contain, we don't have S2. We call it 0. Number 3, we have minus 3. Then we call it 8. Augmented matrix, don't forget. Here we have 2, 2, 9, 7. Here we have 0, 1, 5, negative 2. Now we have augmented matrix. From then we can begin at the leftmost non-zero column, which is a pivot column. Select a non-zero entry as a pivot and interchange, if necessary, to move to that entry into the previous position row 1. But in this case, you discover that we already have 1. We don't need to interchange in this case because the first entry point is 1. This is 1. So you don't need to interchange anything. You don't need to reduce anything. Assuming it's 2 and we have the other side to be 1, we can interchange them so that the leading entry point will be 1. So in this case now we proceed by saying, so we can now create zeros in all entry below our pivot point. So how do we do that? It's still the same reduction. So how do we reduce this? You agree with me if I said 2 minus row 1 plus row 2 to give me row 2. 2 multiplied by row 1 minus plus row 2 will give me another row 2. So how do we do that? It's very simple. Row 1 will remain the same, 0 minus 3, 8. So we have minus 2 row 1, which is 1, plus 2, which is equal to 0. So this place turns to 0. Then minus 2 into 0 plus 2, which is still 2. You write the 2. Then you have minus 2 into negative 3 plus 9, which is what do we have now? We have negative 6, right?
15.
We have what? 15. That is, minus times minus will be positive, plus 9 will be 15. Thank you. Then the last point, which is augmented side, will be minus 2 in brackets 8 plus 7. What do we have? Anybody? So for the R3, still remain the same, 0, 1, 5, minus 2. So we need to repeat the process for remaining rows. Ignoring rows you have already applied algorithm to. So, but we need to repeat the process. But before then, I need in these points, remember, this place needs to be reduced to 1. It's very simple for that. I can easily do that. 1 over 2 R2 will give me another R2. So I can do it by saying 1, 0, minus 3, 8, 0, 1. This will give me 15 over 2. This will give me minus 9 over 2. Don't bother yourself about the fraction. Everything will still be sorted. 1, 5, minus 2. So the next thing we need to do is to reduce to form another row 3. How do we do that? Another row 3 will lead us to R2 negative R2 plus R3 will give me R3. So I can proceed by there. Remember, my target here is this gentleman. That's why I said negative R2, because you have to be working with it according to the plan, according to the algorithm we are working on. 1, 0, minus 3 into 8. You write it the way it is. So we have 0, 1. I can divide this one by calling it 7.5. This one will be negative 4.5. It allows. So negative R2, meaning minus 1 plus 1. 0, 0. That's a new R3. Then the next thing is negative R2, which is minus 7.5 plus 5. It will give me negative 2.5. Then the last one will be minus 4.5. Remember, minus this, plus minus 2. So when you add it together, you will have something similar like 2.5. So now that we have this, remember your target is this diagonal element. Don't forget. Must be a pivot, which is you must have 1 in all true. So how do we solve this one? We'll repeat the same process again. Who can tell us how to make the last entry, the last row 3 to be 1? How do we do it? Anybody? Just look at it very well.
1 over.
Yes, 1 over. Yes.
Negative 2.5.
Negative 2.5. Thank you. R3 to R3. You know, the beauty of this particular question is you can take it from any angle you like. Just make sure you obey the algorithm and you are good to go. So R3 alone we need here 1, 0, minus 3, 8. Here we have 0, 1, 7.5, negative 4.5. Then here we have 0, 0, 1, and negative 1.
Did Babalola say anything? No.
Any question? Okay. So we have this.
And I filled up the water. But I said I filled up the water, but there's no ice yet because it needed water.
So we have this. So that is, we already on the step 3. That is the 3rd step. So at this point now, we have, who can tell me the name of this particular matrix? out of the two metrics that I show us initially. Can we call it reduce or can we call it echelon form? Which one? Please put it in the chat. If you are following the class, kindly put it in the chat. Let's see what you call it. If you are here in the class, what is the name of this particular? Yes. Okay. Someone said reduce form. You can just put it on the chat. Yes. Another. Please go ahead, put it on the chat. Someone said reduce form. If you believe it's a reduced form, write your own. Let's see. No one is writing reduced form. Okay. Kendra, reduced form. Raymond, reduced form. Who else again? Only 2 people in the class out of 18 or 17 of us. Okay. Okay. Reduce. Okay. Gabriel, reduce. Okay. Who else again, please? Alicia, reduce. Okay. So remember the difference between the reduced and echelon form. If you're following me and I believe you are writing, you are also writing something. Don't just watch this. Make sure you write in the class when it comes to mathematics. Now look at the difference. This is echelon form. Why? Look at this. And look at the reduced. See the reduced form. So let's continue first. By the time we finish this, you'll be able to judge between the two. So now for step 4 says, ensure each pivot is a 1 using scaling as necessary. So don't forget we have this step. We already done that. But it now said something in step 5. It said begin with the right most pivots and working upward and to the left. Use the row reduction to create zeros above each of the pivots. So what it simply means is, how do you make this guy to be 0? Is already 0, 0, 0. Because they are the one above our pivots. How do we make them to be 0? Okay. So what we need to do is, from here, you can tell us what to do from here. Which one do you think is easy to reduce? I need a sincere solution to this problem. Which one do you think we can reduce? Anybody? So I pick negative 7.5 R3 plus R2 to form my new R2. Do you agree with me? So it's going to be 1, 0, negative 3, 0, 1. Remember, we want to form new R2. So it's going to be negative 7.5. R3 is what? 0 in this case. Plus R2 is 0 equals to 0. So we add 0. Then negative 7.5 of R3, 0, plus 1 equals to 1. So we have 1 here. Negative 7.5 of 0, sorry, of 1 plus 7.5. What do we have? In this case, we have negative 7.5 plus 7.5, 0. So we have 0 here. So the last one, negative 7.5 of R3 is negative 1 minus, because that's minus 4.5. What do you have? Anybody? I have 3 here. So in this case, we have 0, 0, 1, negative 1. Now, remaining one, you can see that we need these 3 also to be 0. How do we make 3 to be 0? So you agree with me if I put it this way, if I said 3R3 plus R1, it will lead to my new R1. 3R3, because you have to be careful when you are doing that, because anything that will affect the pivot value must not occur. So in this case, I have my R2 is the same, my R3 is the same. I have 3, negative 1. Here we have 3 into R3 is 0 plus 1 plus R1, which is 1, is equals to what? Is equals to 1. So you put 1 here. 3R0, R3 plus 0, 0. 3 of 1 minus 3 equals to 0. So this is 0. Then 3 of 3, 3 of negative 1 rather, plus 8. What do we have? We have 5. Now, can you change your mind now for those of us that said reduce before? So you can see that we have reduced row reduced echelon form. Both upper triangle and lower triangle, they are all zeros, except diagonal matrix. So therefore, our x1 will be equals to, so x1 in this case will be 5, s2 is equals to 3, s3 is equals to negative 1. How do I know it's 5? How do I know I'm correct? I can check. Let's go to the equation. We can check this. Equation 1 says S3 minus 3S3 equals to 8. So let's substitute x1 there. X1 is 5 minus 3 into S3, negative 1. When you add it together, you have 5. Minus times minus is plus 3, which is equals to 8. You are right. If you check others too, this is how you check whether you are correct or not. Substitute your x1, s2, s3 back into the equation. Then, if you are getting the same thing outside, that means you're right. Any question, please? Okay. We discussed the what we call free variables sometimes ago. I'm not sure whether it's your class, I guess. Okay, let's quickly look at the free variables. Whether it's we're talking about the solution now. Solution sets and the free variables. We want to see whether we have a consistent system with infinitely many solutions, or we have inconsistent. It's very simple. How do we do that? Let's look at the example here. We have 1, 0, 5, minus 5, 1, 0, 1, 1, 4. Then here we have 0 all through here. So if I want to write this one out, how do I do that? I can rewrite it by saying x1, because 1 is here, meaning x1 plus 0s2. I'm writing it in form of system of equation now. Minus 5s3 equals to 1. Then for the second equation, I'll have 0s3, 0x1 plus s2 plus s3 equals to 4. The third equation is 0 equals to 0. So if the third equation is 0, now let's look for x1. I can calculate my x1 from this. I can say x1 is equals to x1 is equals to, I can take this one to the other side, 5x3 plus 1. If I take this one to the other side, it will be, that means my x1 is equals to this. Then my s2 is equals to what? From second equation, what is my s2? Since my s2 will now be 4 minus x3. Because if I take this one out to the other side, remember I'm looking for s2, and x2 is not in equation 1. I can only get my s2 here. S2 is not in equation 3. I can only get it in equation 2. That's why we make it S2. But at this point now, what will be my S3? We call S3 a free variable. Because if you look at it, it simply means free variable can take on any value. Once you choose a value for your free variable, it will determine the value of the other basic variables. The basic variables, we know them, they are here. But free variable, that is, you can assign any value into free variable. Now let's look at it. Because of our time, for the said let's S3 equals to, if I say let's S3 equals to, let's say S3 equals to 3 or 2. If I say let's S3 equals to 2, let's say S3 equals to 2 here. So if S3 is equals to 2, what is my X1 be? My X1 will be 5 of 2 plus 1, which is equals to 10 plus 1, which is 11. Then S2 is equals to what? 4 minus 2, which is equals to 2. Therefore, I have my X1 to be 11, comma, S2 to be 2, comma, and S3 to be 2. So I can also check this one. If I said let's S3 equals to -4, or let's say -4, or okay, -4. If it is -4, S1 will be what? Will be 5 into -4 plus 1, which is equals to, this is -20. -20 plus 1, we have -19. -19. So let's say S2 is equals to what? For S2, we have 4 minus -4 equals to 8. So I have my X1 to be what? -19, then 8, and here we have X3 to be -4. So what it simply means is there are infinitely many solutions. There are infinitely many solutions in this type of the problem. So we know today now, we're able to discover the echelon form, row reduced echelon form, the algorithm to write the row reduced echelon form, and to see which one is the basic variable and the free variables. So these are the things we are able to discuss today. So any question, guys?
Hello.
Yes.
I was able to complete the first 2 assignments on WebAssign, but now I'm not able to see any assignments. Is there a reason for that?
Oh, okay. The first one, you discover that it's not supposed to be shadowed because I will send assignments to you today. The main assignment that you're supposed to do. That was the previous class. So the system just schedule it automatically. So for this particular one, the first assignment is yet to be released. I will release it as soon as possible today or next, so that you guys will be able to have access to it. I believe all of us have signed for the web assign. How many of us don't have Cengage yet? Raise up your hand, please.